All right. So guys, when you are solving a radical equation, what do you think you are going to need to be able to deal with? You're going to have to simplify radicals, yes? Because you got to get rid of them. You're also going to need to do, since it's an equation, you're going to have to be able to do algebra, yes? So let's look at this situation, and notice I say there are two things to do with each question. There are state restrictions and solve. So we have to discuss two of those things. What does the word restriction mean in English? Forget about math. What does the word restriction mean in English?
Something you're not allowed to do.
Yeah, something you're not allowed to do. So normally when we solve an equation, we say x equals something, right? If I add this, 3x plus 9 equaled 30, we would solve it, yes? Minus 9 from both sides, divide by 3, and x would equal 7, right? And that is the only answer to this question, correct? So the restrictions on x here is x must equal 7. Okay? Now look here. Do you know, before we've done any work, what x is? You don't, do you? But in a radical equation, there are certain things x cannot be. All right? And that's what the restrictions are. Restrictions, and I write that over here. Restrictions are what you cannot have for an answer. Okay? Now, where in this expression, x lives right here, so I only have to care about one spot, yes? What do we know about square roots that will allow us to talk about what x isn't allowed to be? What do we know about square roots? What do I know about, Lucas? X can be negative, but radicands, square root of a negative number, doesn't exist, yes? Not in our number system, right? So to do restrictions, anything that's a radicand has to be greater than 0. Okay? 0 or greater than. So we always do our restrictions by taking any radicands. Radicands must be greater than or equal to 0. So we got to do double algebra here, yes? So what's the only radicand I have in this equation? I have 2x minus 1 greater than or equal to 0. Then I solve that. 2x is greater than or equal to 1. X must be greater than or equal to 1/2. So if I do a whole bunch of work with this question, and I find my x is less than 1/2, is that answer allowed? No. So there's no answer to the question. Do you understand what I am saying? So we always have to find our restrictions. And we always find in the same way. What if there's more than one radicand? Then you got to do all the restrictions. Okay? Now, sometimes those restrictions will double up on each other, right? Like if you find out this, x must be less than or equal to 8, and x must be less than or equal to 10. What would that mean? Which is the only restriction there that you need to worry about? Why? Right. Everybody cool? Okay. So we've done our restrictions. So we know how to take care of that. We know that. Now, Some of you already know how to solve these, but some of you don't. What do you think is your job here? What is your job anytime you see an equation like that? To get x by itself, right? And how do you get x by itself? How do you isolate x in a regular situation? You move everything that's not x to the other side. That seems fair. Can we do that here? All right. Well, let's do that. What would be our first step then? So step one, Kelvin says, isolate x. That's Kelvin's first step. So what would that be? That would mean we'd have root 2x minus 1 equals what? 7. Is everyone okay with that? Everyone agree? Okay. I'm going to change Kelvin's choice here from isolating x to this. Isolate the radical. That needs to be your first step. Get the whole radical alone. Now, what do you think our next step is? You know, stop it. What would our next step be? You guys are smart kids. You've never seen this before, but you've seen math. Divide 7 by a radical? Square root? Square it, right? Because in algebra, you do the opposite of what you see to get rid of it, right? So you see a square root. So what's the opposite of square root? You square the radical. Because what did we just learn? What happens when I square a radical? It disappears. So what do I have on the left? 2x minus 1. Now, what do I have to remember to do? Same where? Why? Because it's not equal if I don't. I got to square both sides. Square the radical and everything else. So what do I get now? 2x minus 1 equals what? 49. And now it's just normal, right? Step 3, solve. So 2x equals 50. X equals 25. Yes? And in grade 9 and 10, we're done now, aren't we? But in grade 11, there's a fourth step. Check against the original, and someone just said it over there, the restriction. Is x greater than 1/2? So we're okay on the restriction. Now we got to see if it works. X is 25, right? What is 2 times 25? 50. What's 50 minus 1? 49. What's the square root of 49? 7. Is 5 plus 7 12? So are we right? We are. We check with the original, which is 5 plus root 2 times 25 minus 1 equals 12. 5 plus root 49 equals 12. 5 plus 7 equals 12. Now, here, somebody usually says, but Mr. Myers, the root of 49 is what? Only 7? Plus or minus 7, isn't it? Right? So here we have to remember that we are looking for the positive root, which has a special name, and it is the principal root. Everybody cool? We know that negative 7 times negative 7 is 49. But this symbol, math guys agree that when you're talking mathematically, you want the positive one. Everybody cool? All right, so let's look at the very next question. What's different? There's two ends, right? Now, one of those ends has some complicated crap around it, yes? So we should get rid of that first. But what should we do before we do even that? Check our restrictions. What are our restrictions? 5 minus n has to be what? Greater than or equal to 0. Yes? So how do I solve that?
Negative.
Negative n has to be greater than or equal to negative 5. Then what? Greater than? What do I have to do to the sign when I do anything with a negative? Flip it. N has to be less than or equal to 5. And that makes sense, yes? Because if n is bigger than 5, what do I have under the radical sign? What? What do I have under the radical sign if n is bigger than 5? A negative. Is that allowed? No. So n has to be less than 5. So we're going to do a bunch of work, right? And if one of our answers is greater than 5, it's not going to be a right answer, is it? So let's run through this. So what should I do first? Isolate the radical. Here it is right here, yes? It's negative, right? So do we want to deal with the negative? So what if I move that over there? What will happen? It'll be positive. So I'm going to have root 5 minus n, yes? And if I'm isolating the radical, what do I have to do with this negative 7? I got to move it back over here. So I end up with n plus 7. Is everybody cool with that? Okay. Now, what's our next step? What do we want to get rid of? What do I want to get rid of? The radical. How do I do that? Square it. So what am I going to have on the right? 5 minus n. Done. Because the squaring just gets rid of the radical. Right? What do I have to do to the left side? Square it. We remember how to square these, yes? It's just binomial expansion. So it's n squared plus 14n plus 49, yes? Right? Now what don't you like? There's n's all over the place. So our job is to get rid of the n's, yes? Combine like terms. Okay. So are there any other n squareds? Nope. So I got n squared. Are there any other n's? Yep, right there. What do I do with this n? I bring it over to here, right? And what do I get? 15n. What do I do with this 5? I bring it over here. Minus 5. 49 minus 5 is 44, yes? And what does that equal? 0. Now this is what I needed to remind you of. What do I do with the trinomial? Factor it. I need factors of what that add to what? Factors of 44 that add to 15. What are they? 11 and 4. So I got n plus 11 and n plus 4. Now, for that to be true, one of them has to be 0, yes? So, if this one's 0, it's going to be negative 11, right? If this one's 0, it's going to be negative 4, right? Do both of those satisfy our restriction? Yes. But I got to check them now, don't I? Well, those are both less than 5, right? So now I got to check them. Negative 11 minus the root of 5 plus 11, because negative 11, right? Does that equal negative 7? Negative 11. What's 5 plus 11? 16. What's square root of 16? 4. Is negative 11 minus 4, does that equal negative 7? No, it doesn't. So is negative 11 a right answer? No. What about negative 4? Negative 4 minus the root of 5 minus negative 4 equals negative 7. What's negative 4? What's 5 minus minus 4? 9. What's the root of 9? 3. Is negative 4 minus 3 negative 7? Yes. So this is our one and only right answer. Is everybody good? Now remember, nothing new today, just what you already know about math, but again, we're asking you to apply everything you know about math now, yes? So let's look at this. Is my radical isolated? It is. So what's my next step? Square everything. And what do I get? P squared equals 2 minus P, yes? What's ugly about that? P on both sides. P on both sides. P. He highlighted it with yellow. P squared plus P minus 2 equals 0. And what would you do there? I'd factor it to get what? Two and 1.
You have my dice?
I do not have your dice.
No?
I have not had your dice in quite some time.
Do you have any dice?
I have a dice app on my phone.
That.
Sorry, man.
Square both sides, man.
We already squared both sides way up there.
Pretty good.
And now we're at P minus 1. We were laughing. Well, we weren't laughing. I was laughing because there was P on both sides. But they didn't think it was funny.
That's because it's Monday morning and they're all dopey.
Yes. So what are my two options there? Negative 2 or positive 1. Now, what didn't we check? Restrictions. P has to be what? Less than 2, yes? Are those both less than 2? So they're okay. P must be less than or equal to 2. They're okay, but what do I need to do with them now? Check them. Go. Which is the right answer? It's a tricky one. Lucas. 1 is the right answer. Root 2 or negative 2 is not. What is 2 minus minus 2? 4. What's the root of 4? 2. Positive 2, because in math we are looking for the principal square root, yes? Not negative 2. Got it? This root is what we call extraneous. It is an extraneous root. Sometimes you'll have 1. Sometimes you'll have 2. It depends if we're doing a cube root. Everybody cool? All right, so you guys try this. Well, not yet. We'll try this one together. What is my restriction, first of all? 6n plus 19 has to be greater than or equal to 0. 6n greater than or equal to negative 19. N must be greater than or equal to negative 19 over 6, which is just about 3, right? So anything, we'll use 3. So what should I do here? You could, but I would just move the n, because that will leave that guy by himself, right? The less steps you can take, the better. So I'm going to get root 6n plus 19 equals 2 plus n, yes? Now what? Square both sides. So 6n plus 19, easy peasy, equals n squared plus 4n plus 4. Yeah? It's binomial expansion. Everyone's cool with that, right? Now what? Collect your like terms, just like you would normally. N squared. Bring this 6 over here. What happens to it when it goes over the equal sign? Negative. So it's minus 2n. And what happens when this 19 goes over the equal sign? Becomes negative, so what do I get? Negative 15. And now I need factors of what that add to what? Negative 15 that add to 2. What are they? N plus 3, n minus 5. Right? So what are my n choices? What does n have to equal? Negative 3 or 5. Is either one of them extraneous? Check.
Yeah.
Which one doesn't work?
The negative 3.
Negative 3 does not work. So there's our extraneous one. Do you still have to check 5? Yes. Does it work? Yes. Everybody good? All right. You guys try E by yourself because it's an easy one. Tell me the restrictions and the answer. Hey, tell me the restrictions and the answer on E. And this one's easy because there's no factoring. It's just practice. Oh, I'm very tired today. I'm so sorry, you guys. What? Any radicand has to be greater than 0. I threw you that one.
Thanks for saying it for me that time, Joel.
Don't beat yourself up, Joel. This is the first time you've seen this. And it's first block Monday morning, and you're in the most difficult math class, probably the most difficult class you've taken in high school.
That's true. Statistically, I couldn't build a fridge right now.
You could build a fridge, just statistically it would be more likely to fail. All right, would anybody like the magic pen? You want the magic pen, Kelvin? Yeah? All right. Oh, no, it comes to you, buddy. Go. No pressure.
It won't like rub my hand, will it?
No.
Okay. That's really is that right?
I don't know. Is it? If only there was some way to check.
Right? Oh, yeah. Okay. So
What's 5 times 6?
30.
30 minus 5.
25.
What's the root of 25?
5.
Is negative 8 plus 5 negative 3?
Yeah.
So is it right,
Yeah.
Kelvin? I ask you.
Yes.
You're darn tootin' it's right. How many people got it? That's an easy one, right? Because there's no factoring. Did Nav screw it up? All right. Hey, your screen is right side up, but mine is turned upside down. It won't stop me. It's already stopping me. What the heck? There we
That's
go.
upside down for us.
Shut up.
No.
That would piss me off, Bryce.
Well, it was briefly.
Was it?
Yeah.
Okay. So F. What happens in F? What's the first thing I got to do? Restrictions. Negative 3m plus 10 greater than or equal to 0. Negative 3m greater than or equal to negative 10. M less than or equal to 10 thirds. So m has to be less than 3 1/3, yes? So anytime I get an answer of bigger than 3 1/3, it would be out the window. So what do I do here? Same stuff I've been doing all the way along. Isolate the radical. So I'm going to have root negative 3m plus 10 equals what? 4 minus m?
No. Minus 4 and
M minus 4. Because the m didn't move. The positive 4 came over here. Then what? Then what? Then what? Then what? Then what? Square everything. Negative 3m plus 10 equals m squared minus 8m plus 16. Yes? Then collect your like terms. 0 equals m squared minus 5m plus 6. Yes? Yeah? Okay. Now what? What are the factors that I need? Negative 6 and positive 1? Ooh, Sydney! What is it? Which 3 and 2? Both are negatives. So what is m? M has to be 3 or 2, correct? Now, what's the question that every kid asks of their teacher when they get to the last section? Is this right, Mr. Myers? Can you check it for me? And what does Mr. Myers say to you? Check it yourself. How? By putting it back in. What's negative 3 times 3? What's negative 9 plus 1, or plus 10? 1. What's the square root of 1? 1. What's 4 plus 1? 5. Does 5 equal 3? No. So 3 doesn't work. Let's check 2. What's 3 times negative 2? Negative 6. What's negative 6 plus 10? Positive 4. What's the square root of 4? 2. Is 4 plus 2 6? Does 6 equal 2? No. Oh. So what's the answer? There isn't one. There is no answer.
Can we check every number just to make sure?
Okay? Now, just for fun, if you were to graph this, no. It would be a U shape, and it would be floating in the middle of nowhere. We'll come back to that in 2 units. Oh my good gravy. How would you like what? There's no roots. No roots. Okay? This is the hardest one. Why? Because there's how many radicals? There's 2 radicals. And we got to isolate radicals, don't we? So what are my options here?
Give up.
Let me ask you this then. Which of those 2 radicals is it easier to isolate?
The cube root of x.
That or that?
That.
First one is easier to isolate. So how would you isolate it, Nav? You would divide here, wouldn't you? So now, Nav says it's easier to isolate this big guy. I say no. If I divide that side by root x, and I divide that side by root x, is my big radical now isolated? X minus 7 equals 12 over root x. Now, the question becomes, how many of you looked at that and were like, a great many of you. But every time you do a step, what happens? It gets simpler and it leads you to the next step, right? Even if you didn't know what to do here, you know something here doesn't look right. What is it? A radical denominator, right? So do you know what to do with that? What is it? Multiply what? I could multiply by root x, couldn't I? Right? So if I multiply this side by root x over root x, that's something I could do, yes? Everyone agree? Don't write it down yet. That's something I could do, though, yeah? Okay. What else is something I could do there? I could square both sides, couldn't I? Because wouldn't squaring this get rid of this? So I have 2 options given to me. They both would work. So I'm going to use this one because by squaring it, I get rid of 2 things, don't I? I get rid of this root and this root. Got it? All right, so let's do it. What do I get on the left side now? X minus 7. What do I have on the right side? Ooh. 144 over x. Everyone's okay, yeah? Now what would you do with that? Think to grade 9. What don't you like there?
Dividing by
I don't like that x in the denominator, so what do I do to it?
multiplying.
Multiply both sides by x. What happens to this x? Cancels. This is now x squared minus 7x equals 144. Oh, now what? X squared minus 7x minus 144 equals 0. And now what? Factor. And it's x plus 9, x minus 16. So what are the x choices? Minus 9 or 16. Mr. Myers, can you check this? No. Joel, can you check that? Yes. Which is correct? Which is correct? 16 is correct, and negative 9 is wrong. Why? Why is negative 9 wrong? You didn't even need to do math. Kelvin? Right there. Negative 9 minus 7 is negative 16. That's a negative root, right? So that has to be extraneous. You guys do the next 2 pages now. Yep, 49 and 50. Do that right now. Work on it together if you want. No. Yes. I'm going to make the next 51 and 52. 51, 52, and 53 are going to be our classroom review work tomorrow. And we'll talk about... do you guys have page 54 in your book, test reminders? That's what we'll do tomorrow. We will go over 51, 52, and 53. We'll work on it in class. We'll talk about test reminders, and we will write our test on Thursday. There's no school Friday. I don't want you guys leaving for a 3-day weekend on a test. Now, of course, you guys, Thursday is a shorter day, yeah? So, we could do it Wednesday, but then it's going to be the day right after you won't... Yeah. I would rather you guys write this test and have the whole 80 minutes. But I know that you guys also don't like writing the test the day after the review. You like a day to look it over. Okay. Wednesday it is, so you have 80 whole minutes. What? What? The problem with Thursday is all of you are going to be complaining that you need more time. I mean, I don't care. You can write it Thursday. The test is designed to be done in 40 minutes. So it doesn't matter to me. But I could give you guys a test on addition. And you would all be like, I need more time. All right. Thursday is better anyway because it ends the week. I wanted to write it Thursday. This class bumps into lunch, doesn't it? Because Thursday's collab. So you could bump into lunch anyway if you need to. Awesome. Thursday it is.
So it's on subtracting.
Everything on radicals. From simplifying all the way up to radical equations. And you will notice that page 51, 52, and 53 does everything. That's why it's the review assignment. But you can work on it together. You needn't do it on your own at home. Everybody Gouda?